Good evening, everyone.
Good
Am I
evening.
audible? Am I
Yes.
audible? Good.
Yes, sir.
Yes. So this is going to be our first class of the test series part, right? So when I saw the group, I felt that most of you have a doubt of what is going to happen. I'm just going to give you a brief of what is going to happen in these sessions. Okay. If you see, we have already released the schedule, where in the first 3 pages we'll be having the schedule for the tests. Right? Did you get a chance to go through it? You have all the test dates and the topics of the test topics that will be dealt in those particular tests. Did you all get a chance to go through it?
Yes, sir.
Yes, sir. Yes, sir.
Okay. After that, we have certain chapters name given, right, from 6 to 7, 7 to 8, like that, whichever is given for a particular timing. Those classes are actually revision classes. Okay. So you have a revision class. So before you write test, we will be teaching you those chapters. Only then you're going to write the test. Okay. It's not like directly you're going to sit and write the test. So these revision classes will help you because we'll try to run through each subtopic. Okay. And secondly, we'll be having a paper discussion session after each test. If you see that, there'll be written paper discussion session on the immediate day itself. So with respect to the test part alone, you're going to come to the institute. Apart from that, everything else is going to be completely online. Is it clear?
Yes, sir.
So having said this, let's quickly get into the main part. So today, what is the topic? So we are going to discuss electrostatics, right? If you see electrostatics, there are 2 classes given. So in those 2 classes, we are going to discuss or revise the concepts and mostly concentrate on problems that are related to the course. Is it clear? So with this, shall we get started?
Yes, sir.
So one point I would like to mention here, see those who are actually joining for the test series part alone, there's going to be the first class you're going to attend. So I'm just informing you that if you have any clarification that is needed, please don't hesitate to stop me. So it doesn't mean that others should not ask. You can also ask, since you guys already know me. I'm not telling that point, but those who have joined newly, ensure that you're getting your doubts clarified. Okay, if you have something, don't wait for anything. You can stop me and get it clarified. Okay, so please make the session interactive. So with this, let's get started. Okay. So I hope you're able to see my screen.
Yes, sir.
Did someone call me? Okay. Okay. So I'm going to go subtopic wise. So chapter 1, electrostatics, right? So electrostatics is a branch of physics where we are going to deal with the charges that are going to be at rest. We know this fact, right? So under electrostatic, what are the 2 important branches we are going to discuss? Under electrostatics, what are the 2 important branches we are going to discuss? So we'll be discussing about the electric charges and fields, followed by electrostatic potential, right? So that is the next chapter, electrostatic potential and capacitance. If you see, these two chapters fall under the same branch of physics called as electrostatics, right? So having said this, we'll get started with the first important subtopic. That is, we know that electrostatics mainly is going to deal with charges, right? So what are the basic properties of charge that we already know? Can you all tell me? What are the basic properties of charges? So first is,
Charge is conserved.
so charge is quantized, second, conserved, and third is, it follows, it has the additive nature. Am I right? So what do I mean by charge is quantized here? What do I
Charge,
mean by,
charge enclosed by system is integral multiple of
so Q will be equal to plus or minus N into E. So what do I mean by conserved here?
Charge can neither be created nor be discharged. It can be transformed from one form to another.
That is also there. But if you say the total isolated charge present, the total charge present in an isolated system is going to be conserved. What is it? The total charge present in an isolated system is going to be conserved. And third is additive nature of charge. So what kind of quantity is charge? Is it a scalar quantity or a vector quantity?
scalar.
It's a
Yeah,
scalar. So when I say additive nature, you need to do the scalar addition. So to be more specific, more better than saying scalar addition, I can say we need to do the algebraic addition. That is, if I give you plus 5 microcoulomb and minus 3 microcoulomb, what are you going to do to them? When I say add them, what will you do? The final answer will be plus 2 microcoulomb, right? You will not write it as 5 plus 3. You write it as 5 plus of minus 3, right? So having this concept in mind, let's get started with the first set of problems. So we are going to see some examples based on the quantization of electric charge. We'll see what are the formula used. So what are the formula used, guys? Q is equal to N into E, where N stands for pure integer. And when I talk about the mass, so what is going to be the mass that will get transferred from one object to another? If I take one object and rub it against the other, what will happen is there will be an electron transfer taking place from one to another. So how many electrons can get transferred? Integral multiple will get transferred. Multiplied with the mass of each electron is going to give us what? Is going to give us the amount of mass that has actually got transferred. Can I say that?
Yes, sir.
Right. Now, if you see the value of E and Me is known to us. E is the charge of the electron, which is 1.6 into 10 power minus 19 coulomb, and mass of the electron is 9.1 into 10 power minus 31 kilogram. Right. So let's quickly run through the questions that are based on this concept. Can you tell me which among the charges minus A or plus A is going to be of more value? Even without thinking, you can tell me. Which is bigger, minus K coulomb or plus K coulomb? Sir,
Minus
and this part is how many electronic charges form 1 coulomb of charge? Can I have some answers?
6.25 to 10 power 18.
How did I get that?
Q equal to NE.
So when you apply Q is equal to NE, what are you going to get here? Are you able to see me? Yeah. Yeah, tell me. So which one is bigger in the first place? Minus A or plus A? Okay. So I'll do the second part. Q is equal to N into E. Q is 1 coulomb. 1 coulomb is equal to the number of electrons. I'll take it as N into charge of each electron is 1.602 into 10 power minus 19 coulomb. So N will be equal to how much? 6.25 into 10 power 18. So 6.25 into 10 power 18 electrons constitute to generate 1 coulomb of charge. So which is going to be higher? Obviously, so you tell me which one, minus A or plus A, which one is going to be more? Negative or positive? Which one is more? This one.
Positive.
That's it.
Positive,
That's
sir.
it. That is the answer. That is what you need to answer. Sometimes it will be tricky that you will start thinking so much. So there is a comb that is drawn through a person's hair on a dry day, and it causes 10 power 22 electrons to leave the person's hair and stick to the comb. Calculate the charge carried by the comb. So 10 to the power 22 electrons leave the person's hair and stick to the comb. Means, has the comb acquired electrons or lost electrons?
Acquired.
Acquired electron.
Has acquired electrons. So what does it indicate? It is going to have negative charge. Am I right? So what is going to be the charge that is present on it? Q will be equal to N into E. N is 10 power 22 into 1.602 into 10 power minus 19. Can I say that? 1.602 into 10 power 3 coulomb with a negative value. So this is going to be the total charge present. So 1.8 into 10 power minus 3. Correct. Varun, check it. Is it minus 3? Is it not plus 3? Yeah. So next one. So minus is this answer. So can we go a little faster? What is that? Don't worry. Sorry guys, there was network issue. Just give me a minute. Yeah. Do this one. No. What is the answer for this? If a body gives out 10 power 9 electrons every second, how much time is required to get a total charge of 1 coulomb from it? So how to proceed? If an object releases 10 power 9 electrons every second, so how to proceed? Tell me.
Sir,
Tell me.
sir, 10 to the power 9 electrons is being released in 1 second, sir.
1 second.
So, by quantization, we'll say like 6.25 into 10 power 18 electrons in X second.
Okay.
So,
So you want to take it like this. You want to follow unitary method. So 10 power 9 electrons take 1 second. Then 6.25 into 10 power 18 electrons will take how much time? Is that what you want to do? So you want to
Yes.
cross multiply. So what will happen? 6.25 into 10 power 18 divided by 10 power 9. This will be the answer. So this will be 6.25 into 10 power 9. Right? It is going to take this much time. Am I right?
Yes, sir.
Yes, sir.
So they've given it in terms of years and all. See, this one is not needed. The next set of problems that we are going to do is based on Coulomb's law. See, here I'm only focusing on the board part, okay? I'm not getting to the competitive exam part or something. That is why I told you the previous problem is not needed. They will not ask you because the mole concept and all will come into the, they'll never question you that kind of, they'll never put that kind of a question, okay? So don't worry about it. Next is problems that are based on Coulomb's law. So what does Coulomb's law mainly speak about? It says that if you have two, can you please fill the statement if it has two? What charges?
Equal and
Point
opposite
Equal
charges.
and opposite.
Hey, that is the dipole, Ra.
Point.
I'm asking Coulomb's law.
2 point charges.
You need 2 point charges. If you have a system of 2 point charges separated by a finite distance, then the force of attraction or repulsion between them is given as magnitude of Q1 into magnitude of Q2. That is, it is directly proportional to the magnitude of Q1 into magnitude of Q2 and inversely proportional to the square of the distance of separation between them. Am I right? So what will happen to the force? So F will be equal to K times Q1, Q2, the whole divided by R square. What is the value of K? 1 by 4 pi epsilon naught. So how much is that value? It is going to
9
be,
to 10 to the power 9.
you are able to see the number here, 9 into 10 power 9 Newton meter square per Coulomb square. I hope everybody knows how you got that value. Am I right? Now, the question is, 1 by 4 pi epsilon naught is used when the space between the charges is vacuum or air. Whereas, if it is filled with a dielectric medium, what do you mean by dielectric? Can someone tell me?
Insulating medium.
So something like an insulator, right? So if you have a medium that is restricting the charges to communicate among themselves, then what parameter comes into picture? You will be using something, right? The denominator. You will not write it as epsilon. You will introduce a constant called as
Kappa.
epsilon r. Do you want changing the network? My voice better now? Okay, listen. So there is something called as epsilon r that is there. What is epsilon r? Can someone tell me? It is called relative permittivity. Am I right? So what is going to be the value of epsilon r? It will be epsilon divided by epsilon
Naught.
naught. What is epsilon? Epsilon is the permittivity of that medium and epsilon naught is the permittivity of free space. Okay. I'm sorry, there is some lag. I'm not sure why it is happening. We have a good bandwidth only. Let me check if that issue still exists. Can someone please let me know if my voice is audible or is it breaking?
Audible.
So now it's fine.
Now it's fine. Okay. Now listen to this carefully. So I'm repeating it, this epsilon r. I hope everybody knows this term. It's called as relative permittivity, right? So epsilon r is equal to epsilon divided by epsilon naught. What is epsilon? Epsilon is called as the permittivity of that given medium, and epsilon naught is the permittivity of the free space, right? So having all these things in mind, if the force is to be calculated in any other medium other than air or vacuum, then what is it going to be? It will be 1 divided by 4 pi epsilon into Q1, Q2 divided by R square. See, if you know this formula, well and good. If not, make a note of it.
Sir, you aren't audible.
Sir, you are muted, sir.
Oh, sorry. Yeah. So any other, tell me the other name for relative permittivity. It's called dielectric constant, right? So based on based on Coulomb's law, let's try to solve the problems. So the electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 power minus 9 Coulomb. Sorry, Newton. Oh, it is a force that is given. So F is equal to 3.7 into 10 power minus 9 Newton. When they are separated by distance of 5 angstrom. So angstrom is how many meters? 5 into 10 power minus 10 power minus 10 meter. Now, how many electrons are missing from each ion? Read the question carefully. They are not asking you what is the charge present. They want the number of electrons that are missing. So first of all, can you find the charge and tell me? So how much is going to be? F is equal to K Q1 Q2 divided by R square. But what have they given here? Q1 and Q2 are the same. They both are positively charged ions carrying equal charges, right? So force is how much? 3.7 into 10 power 9 is equal to 9 into 10 power 9 into Q1 into Q2 is going to be Q square divided by 5. Here it is going to be 25 into 10 power minus 20. Can I write it like this? Right? So this implies 3.7 into 10 power 9 into 25 into 10 power minus 20 divided by 9 into 10 power 9 is equal to Q square. Right? So from here, you will calculate the value of Q. Okay. I'm only going to give you the hint. Calculation part, you guys do it. Okay. Because I need to concentrate on more problems. So Q, you're going to calculate. But according to the question, what are we supposed to do? What should we do?
Find number of electrons.
We need to find the number of electrons that are missing. So once you get this charge, what equation should I write to get that number of
Q
electrons?
equal to NE.
To NE. That's it. Write it, you're going to get the answer. You know the charge of the electron, you get the answer. Am I right? So this part, I hope you can do it. Yeah.
Sir.
Tell me.
Sir, in this problem, we have to calculate the value of root 3.7. Can we just leave it as approximately 1.9?
See, root 3.7 is somewhere, what you do is make that 37 as closer to 36. Okay, so what you can do is 3.7. Why don't you write it as 37 into 10 power minus 10? That would be a more smarter way. No? So that 37 is somewhere 6 point something. So
Sir, how does it become 10 power minus 10?
Because I pushed one value to the left, no? 3.7 is 37 into 10 power minus 1. So 10 power minus 1.
Okay.
Sorry, I'm sorry. The 10 power minus 1 is multiplied with this 10 power minus 9. I took those two into consideration. I'll write it again. I know. Wait, I'll write it. I'll tell you what I did.
Sir, no, I'm getting the final answer as root 3.7. So can I just leave it as 1.9 approximately?
Yeah, that should be fine. So 37 into 10 power minus 10 into 25 into 10 power minus 20 divided by 9 into 10 power 9. This is equal to Q square. So this is what I wanted to write. Okay. So don't worry, they'll not give you this complicated numbers and all. If you're able to solve this faster, definitely in boards you'll be able to solve it faster. But I hope, is everyone clear? Can you give me an assurance if I can proceed to the next one? Yes, sir.
Yes, sir.
So you got 1.97 is what you told, right? So Prajit,
Yes, sir. Like 1.9 approximately.
That's what you will take it closer to the integer because you need to take the integral value. Okay. So try this. There is a free pith ball. Pith ball is something taken from something that looks like a thermocol ball. Okay. So a free pith ball, 8 grams carries a positive charge of 5 into 10 power minus 8 coulomb. What must be the nature and magnitude of charge that should be given so that the second pith ball, which is fixed at a distance of 5 centimeter below. So what are they doing? They're fixing the second pith ball 5 centimeter below the former so that the upper ball is stationary. Tricky one, no? So how to do this? So if I have mass present here, right? It has mass. So how is the weight going to act?
Downwards.
So weight is going to act in the downward direction. When weight is downward, read the question carefully. What must be the nature and magnitude of the second charge so that the first ball is balanced? So if the second ball was not there, the first ball would have obviously fallen down. So for it to be stationary, what should happen? There should be an upward force acting. Am I right? And let me call that force as Fe. Can I? Which is the electrostatic force. Can I do this?
Yes, sir.
What should be the relation between them? Fe should be equal to mg. This is what should happen logically. So if this should happen, what should be the nature of the second ball? It should be
Positive.
positive. Only then they can repel. Now tell me one thing. I wanted to ask this question. So what does Coulomb's law state? It states that the force between 2 point charges is going to be something. They've given the magnitude and everything. My question is, what is going to be the direction along, or what is going to be the path along which the force is going to act? So if
The
these two
line
charges,
joining the center.
so it is going to be along the line joining both the charges. That is more important, right? So since it is acting along the line joining, Fe is in the upward direction, mg is in the downward direction. So what is going to be the mathematical equation will frame? 1 divided by 4 pi epsilon naught into 5 into 10 power minus 8, that is Q1. If I take this to be the first charge, Q1 is 5 into 10 power minus 8. And what about Q2, guys? That's what we need to find. The whole divided by what is going to be the distance square? 25 into 10 power minus 4. Because 5 centimeter is 5 into 10 power minus 2 meter. Squaring it is going to give me 25 into 10 power minus 2. Right? This should be equal to how much? 8 grams. So 8 into 10 power minus 3 into, if I take the value of G to be 10 for instance, because every number seems to be divisible by 5. Okay, if I take it to be 10, I have one unknown and one equation. Will you be able to solve this?
Sir, actually, even if we take 9.8, we'll get an easy answer.
That's fine. Because you are saying because 1 by 4 pi epsilon naught is 9 into 10 power 9. Is that what you're saying?
No,
No,
sir, because we don't have to
because-
divide anywhere. We have to just multiply.
Yeah, that's fine. So here what will happen is this 5 and 25 here will get cancelled. So 9 into 10 power 9 into 10 power minus 8 into Q divided by 5 into 10 power minus 4 is equal to 8 into 10 power minus 2 up. So just for simplification purpose, I took it like that. So Q will be equal to take all the parameters to the right and you'll get the required answer. Okay. So after the class, I'll be sharing this document, don't worry. So you'll have the solutions here. So once you do the calculation, you can always check your answer. So that is why I'm not doing the calculation part. Okay. Shall I proceed? Or is there anyone who's copying? Is everyone clear, guys?
Yes, sir.
Yes, sir.
Perfect. Okay, next one. So this one is not needed. So slightly tougher problem. Coefficient of friction and all they will not ask you. This needed. So you have two insulated charged copper spheres A and B having their centers separated by a distance of 50 centimeters, right? So if I take one sphere and another sphere, the distance between them is separated by 50 centimeters. What is the mutual force of electrostatic repulsion if the charge of 6.5 into 10 power minus 7 coulomb is given to either of the charges? The radii of A and B are negligible compared to the distance of separation. So what is the meaning of it? You can consider them to be point charges. Also, compare the force with their mutual gravitational attraction if each weighs 0.5 kilogram. Okay. So first, let's tell me how to calculate the force of repulsion between them. It's going to be 9 into 10 power
Coulomb's
9.
law.
Yes. 10 power minus 7 divided by r square. That is 50 into 10 power minus 2, the whole square. So this part you calculate, those many Newton is going to be the answer.
Sir, 6.5 into 10 to the minus 7, the whole square, no, sir.
Whole square is.
Fine. So 9 into 10 power 9 into 6.5 into 10 power minus 7, the whole square divided by r square. Right. Now compare the force. Compare the electrostatic force with their mutual gravitational attraction. How you calculate the gravitational attraction? So you know this formula F is equal to G m1 m2 divided by r square. So what is the value of G? 6.67 into 10 power minus 11. Okay. Into m1 into m2 is going to be 0.5 square, which is 1 by 4. Divided by r square is again going to be 50 into 10 power minus 2, the whole square. Am I right? Now you divide both, you will get the required answer. Okay. I hope this part is clear. Now, if you see, the second part they're asking, what are the force of repulsion if each sphere is charged double the amount and the distance between them is half? If each sphere is charged double the above amount. So if I take f dash as the new value, f dash will be equal to k into 2q the whole square. Can I do this? Where if I take the initial charge on these two to be q and q, the final charge after the charge has got doubled is 2q divided by what is going to happen to the distance between them? It is halved. So it is going to be r divided by 2 the whole square. So what will be the final value? It will be 16 times kq square divided by r square. So what is the meaning of this? When this kind of a scenario is achieved, the final force of electrostatic repulsion will become 16 times the initial value. Right? So this kq square by r square you would have already calculated from here. Right? You would have already calculated from F. Take that value and multiply it with 16, that will give you the new force. Second, if the spheres are placed in water, then what will happen? I want a quick answer. It's only one step.
Into 80, sir.
Sir, multiply the
Divided
answer
by
to the first into epsilon naught by k.
Not necessary. No?
Into 80, sir.
Why do we need to
Or
see?
divided
You
by
have
which
already
one?
calculated the force. If you divide that force with the dielectric constant, you're done, no? Correct?
Understood, sir. Understood.
Yeah. So you calculated the force. So the new force will be equal to F divided by the dielectric constant. See, this is another concept that you need to remember. Do you guys remember the concept of polarization in dielectrics? Do you remember the polarization in dielectrics?
Yes, sir.
So when a dielectric is there, no? When a dielectric is placed in an external electric field of value E naught, the electric field inside will decrease by a factor of kappa. Do you remember this?
Yes, sir.
What will happen is the original electric field will be the right hand direction. The induced electric field will be the left hand direction. So E naught minus E in will be equal to E naught by kappa. Do you remember this? The same logic applicable. It is happening because the force is decreasing. Okay. So the next set is, we saw about Coulomb's law. The next set that we need to see is based on the concept of superposition of electric forces. So what do you mean by superposition? When multiple forces are acting between different charges, then the net force exerted by all the charges on one particular charge is going to be the vector sum of all the forces. Right? So if there are multiple charges present in the system, and let's say this is the first charge, and I need to calculate the force experienced by the first charge due to the remaining set of charges, what will I do? I will do the vector sum of all these values. That is going to give me the answer. Right? But before that, I have a question. So if this is Q1 and this is Q2, that is charge 1 and charge 2. You told me that the force will act along the line joining both the charges. Am I right? Am I right? Now, if this force on the left hand side, I call it as F, what is the subscript I need to give it?
F12.
Q1.
F12 or 21?
FQ1.
21 or 12? Correct.
12.
12. So what is the meaning of it? Force experienced
Force
by the,
acting on 1 due to 2.
force experienced by the first charge due to the second charge. So here it is going to be F21. This is a very, very important notation. This we will understand from the concept of vector form of Coulomb's law. Right? So that is why if you see the mathematical equation that they are given, they wrote it as 1, 2, 1, 3, 1, 4, 1, 9. So force experienced by the first particle due to the second charge. Force experienced by the first particle due to the third charge. Like that, it keeps on going. Right? So having this in mind, now you are going to do this first problem and tell me how to solve. So this is slightly tricky problem. Okay, I don't want you to take stress on this because this problem you need to solve using geometric progression. Do this one. This is a textbook one. So what is the answer for this? Consider three charges Q1, Q2, and Q3, each equal to Q, placed at the vertices of an equilateral triangle of side area. What is the force on charge capital Q with the same sign as that of small q placed at the centroid of triangle? See, if this question comes as a 1 mark question, okay, what will be the answer you write?
0.
Why is it so?
All the forces cancel out each other.
Because of the symmetry. Right. Whereas if it comes as a 3 mark question, they're expecting you to write the detailed answer. Then you have no other option. You need to go with the concept of principle of superposition. So how are we going to do that? So there are three charges placed at the vertices of an equilateral triangle Q, Q, and Q. And let's say each side is A. Okay. There is a fourth charge, capital Q, of the same sign as that of the small q, is placed at the centroid of the triangle. Now, what are we supposed to do? Calculate the force experienced by this charge, capital Q, due to the remaining system of charges. How do I proceed? So I'll take the force, if I label this as 1, 2, and 3, and the charge capital Q as 4. if I draw a line joining small q and capital Q, that is from 1 to 4, what should I write this force as? It should be F. Give me the subscript. It should be
F1,
F.
4.
4-1.
Think and tell me. F.
4-1.
2 will add 4. This one is 4.
F41.
It should be F41. Similarly, here it should be F.
4.
F42.
Correct. And this should be F43.
43.
So what will happen? F vector will be equal to, see, these are all very important for course because they take all these notations and you will get marks for it. Okay. So F vector is equal to F41 vector plus F42 vector plus F43 vector. That is a vector sum. Right. But what is going to be the value of F41 in terms of magnitude? Is it not going to be equal to F42? Is it also not going to be equal to F43? Why is it so? Because the distance from the centroid, the distance from vertex to the centroid from any direction for an equilateral triangle is same. Right. So if I take this to be R, this will also be R, this will also be R. So can I say that this force is F? Right. Now, if I take the fourth charge and draw a free body diagram like this is going to be capital F, and this will be capital F. Right. So what is going to be the angle between those two capital F's at the top? It's going to be 120 degrees. This one.
Yes,
Very
sir.
simple. Exterior angle is equal to sum of opposite interior angles. So I have this question from parallelogram law of vectors, right? When two forces are acting at an angle theta, I repeat, when two forces are acting at an angle theta and those two forces are of equal magnitude, then where will the resultant be? There are two forces.
At their angular bisector.
So I hope everybody knows this. If you don't know this point, please make a note. If there are two vectors of equal magnitude acting at an angle theta between them, then the resultant will be an angular bisector. Where will we use this concept in one of the derivations? Sundrajit, can you tell me where do you use it? Where do we use this concept? We use it in one of the derivations of this chapter.
Electric field of
Yes,
the
sir,
diagram
dipole.
equatorial point.
So dipole, where do we use in dipole? Dipole is like
Equatorial.
Equatorial point.
Equatorial point.
when you calculate the electric field due to a system of dipole at an equatorial line, on an equatorial line, we actually use this concept, right? So it's going to be an angular bisector means the resultant is going to make exactly 60 degrees here, 60 here. In a similar way, this will also be 60 and this will also be 60. Oh, sorry, it will be 30, no? This will be 30 and this will be 30. Am I right? So, this force can be resolved into vertical and the horizontal components. What are the components going to be? F cos 30 and F sin 30. Tell me one thing, is there anyone having doubt with how to resolve the components? If so, please let me know it. Clear it immediately. Is there anyone having confusion of where to take cos and where to take sin?
Sir, I do.
Sorry?
I do.
You have it. Okay. May I know who it is?
Given.
U1. Okay. Listen, U1. When there is a force acting like this, if this is going to be 30, okay. So when a vector is there, you know that the vector can always be resolved into two perpendicular components, where one of the perpendicular components will be cos and the other will be sin, right? Now, if you see, if this is a vector I want to resolve along this horizontal, wherever angle is getting included, I repeat, wherever the angle is getting included, that will be cos.
Okay, sir.
So what should happen? This will be cos. And what about this? It will be
Sine.
sine. Okay, using the same logic, can you guys resolve and tell me? This is f cos 30. This is f sin 30. So one f sin 30 is because of this force. Right? One f sin 30 is because of this force. And this force can be resolved into two components. One is along this side. So this is one f cos 30. And another f cos, sorry, f sin 30 is because of this force. So if I draw a clean diagram, it is going to look something like this. So this is 30. This will also be 30. So this is f sin 30 due to this one. And similarly, another f sin 30 due to this force. And f cos 30, this f cos 30 is due to this force. And this f cos 30 is due to the left side force. And remember, there is a force F acting in the downward direction. So tell me which vectors will get cancelled.
F cos 30.
Cos 30 is lost. And what about sin 30 now? Nitish,
Sir, it will add up.
add. So f sin 30 plus f sin 30 is going to give you how much?
F.
F. Because sin 30 is half. So f sin 30 plus f sin 30 will give you F. The upward F will cancel the downward F. Hence the answer will be. So that is why you can say this particular system is at equilibrium. Right? What equilibrium? I want to test this also. I want to
Stable.
see. Subhajit, you are there? Yeah, Kirti, you
Yes,
tell
sir.
me.
Stable
Oh,
equilibrium.
Kirti was answering something. Sorry. Kirti, tell me what kind of equilibrium is that?
A stable equilibrium.
It's called stable equilibrium. So what is the difference between stable equilibrium and unstable equilibrium?
So if it's disturbed from its equilibrium position, it will come and it's released, it will come back to the position. But an unstable equilibrium, if you disturb it and you release it, it will not come back.
If it is an unstable equilibrium, you're trying to say when you disturb it, it will not come back to its original position. Correct? Huh?
Yes,
Is it?
sir.
Is it?
Yes, sir.
Or it's change. Can you slightly correct it?
Sir, it will go back to stable equilibrium.
Yeah, what she I am able to understand what she is telling. See, this concept, where do we apply it? In this chapter itself, there are questions based on stable and unstable equilibrium. Can you tell me where is it? Where is it asked? The torque acting on a dipole. They'll ask you what should be the angle between the dipole moment and the electric field for stable equilibrium and unstable equilibrium. Irka, listen to this. So, listen, if this is a system which is like at equilibrium, which is at rest, okay. First of all, can someone tell me what is equilibrium?
No net
What is
force is acting.
So no net force is acting means, can I say that the object has zero acceleration?
Yes, sir.
Yes. So does that mean that an object can move but still be in equilibrium? Possible?
Yes, sir.
An
Sir,
object, when is it possible? When is it possible?
Constant velocity.
velocity is constant.
Velocity is constant. Very good. So if I take this to be the object, if I disturb this object from its equilibrium position, if it is retracing its path and coming back to the original position. So you created a disturbance in clockwise direction with respect to me. With respect to me, I created a disturbance in the clockwise direction and it retraces the path in the anti-clockwise direction, comes to its equilibrium position. This is called as stable equilibrium. Whereas if you disturb the object and if that object takes a 180-degree turn to come back to its original position, then you call it as unstable equilibrium. So that is why the angle between P vector and E vector, we will either write it as 0 degree or 180 degree, depending on the question. Purida.
Yes,
Right.
sir.
Good. So, okay, this is very simple. Same problem, next, but put in a different. pattern they have given. So there are 3 point charges plus Q, each are kept at the vertices of an equilateral triangle of side. Determine the magnitude and sign of the charge to be kept at its centroid so that the charges at the vertices remain in equilibrium. What is it? One step you should tell them there is nothing.
Plus Q, sir.
Plus small q. So, this is what you're trying to say?
Yes, sir.
But I would say not needed. Can you think better?
For any charge.
Place any charge at any level. To place any charge of any magnitude, it will happen. Why? So,
Because Q1 and Q2 combination would be the same.
that is the logic. So Q1 into Q2 is going to be the same as long as the value of Q in all the 3 charges. See, if the first charge is going to have the same magnitude, second one will also going to have the same magnitude. It can be anything, 2 coulomb, 3 coulomb, 2.5 coulomb, anything. Right? So they asked us to confuse. So what should be the magnitude? Anything. What should be the sign?
Any sign.
Sign?
So any sign.
It can be anything. What she told is right. Yeah, see, I'll tell you the logic, okay? If you take them at the vertices of 3, see, they told that at the vertices, what you have 3 positive charges. But at the centroid, what are they expecting? See, we did one problem just now. In the previous problem, what was the nature of the charge that was kept at the centroid?
SQ.
Capital QR, which was of the same nature as that of the other 3 charges. So when you kept it like this, what we did is, we took the forces like this. Am I right? The forces were away. But when you try to resolve, we could understand that they got cancelled. Had it been negative charge, what would have happened? Had it been negative charge, what would have happened? Still, the forces would have been in the spin. So what is the difference? In the left-hand side, the force was, Q was experiencing a pushing force, means it was experiencing a repulsive force. Whereas when the value of Q is negative, it is experiencing an attractive force. But since the directions are adjusting themselves, again, when you resolve and try to solve the problem, the answer is going to be 0. So, like how? Kirtana, right? Kirtana told or Kirti told? Who told? Okay, both of them were right. Both of them were. Okay. So the charge can be of any magnitude and any. What is it? Okay. So consider charges Q, Q and minus Q placed at the vertices of an equilateral triangle. What is the force on each charge? Q, Q and minus Q. So this is actually a textbook problem. So what are the force on each charge? If I take this as 1, 2, 3, they are asking what is F1. They are asking what is F1, what is F2 and F3. Can you tell me the mathematical expression for F1? F1 as a vector will be equal to F12 vector plus F13 vector. Am I right?
Yes. Yes, sir.
Similarly, F2 vector will be how much?
F21, F23.
That's it.
Plus, sir.
Similarly, F3 vector will be equal to F31 plus F32. Whatever is the charge that is there, you have to leave it. Right? That's how the symmetry goes. So, what is the value of F12? Can you tell me? So listen, F12 is in this direction. F13 is in this direction. So what is the angle between both?
One 120.
120.
So the angle here is going to be 120 degrees. So what is the value of F12? Can you tell me only the magnitude of F12? Can you tell me only the magnitude of F12? Okay.
Q square by R.
Okay, I take the side to be A. So KQ square by A square. What is the magnitude of F13? I'm taking only magnitude. Okay, listen to this carefully. I'm taking only magnitude. F13 is how much? It is also KQ square divided by A square. Now tell me one thing. See, this is another point I've seen people getting confused. Okay, when to take magnitudes and when to take the sign of the charge into consideration. Can someone give me a clarity on this?
So in vector form, we'll consider the sign.
Sorry, come again, ma'am.
In vector form, we'll consider the sign. In normal scalar form, we won't take the sign.
1 minute. If it is vector form, you're saying you will consider the sign of the charge. Is that right?
So yeah, sir, to say if it's repulsive or attractive force.
But I didn't take the charge here. I didn't take the minus here. When I wrote F13, I didn't take minus. No, then according to your logic, it should have been minus KQ square by A square.
So in normal scalar form, we won't consider the charge. I mean the sign of the charge.
Sir,
That you're actually telling the reverse. So when you're
Sir.
dealing with, tell me.
sir, in the vector form, it will actually take the sign by automatically, sir. Since if the force.
That is the reason. So listen to this very carefully. Okay. Why I'm telling this is when you're doing the derivation of electric field due to a dipole, right? If you observe, when we take it at the axial point or equatorial point, in the derivation part, we'll never take the sign of the charge into consideration because what did I do here? I already gave the direction F13. Means I'm trying to say that the first charge is getting attracted to the second charge. Am I right? When that is the case, if I take the magnitude alone into consideration, the angle and the magnitude of vectors will take care of the direction. So I repeat it again, listen. Whenever you're writing a mathematical expression, if you're writing the expression, so what are the terms that are scalars, that are vectors in this chapter? What are the two important points we discussed? One is about the force. Second is about the electric field. They both are vector quantities. So when you're dealing with vector quantities, you will not take the sign of the charge into consideration when you're writing the magnitude alone. Why? Because the vectors, because the nature of the charges will take care of the direction. That is more important for us. Whereas, if the same question was about calculating the potential energy of the system, what is it? So had they changed the question as, instead of saying what is the force, if they say what is the potential energy of the system, what should we do? Then you should take the charges into consideration. I mean the nature of the charge into consideration. Are you able to understand? Okay. So one thing I'm able to understand here is both are of same value. So I write it as F. So if I take a free body diagram of the first charge, this is F and this is also F. Here it is going to be 120 degrees. Am I right? Now the question is, where is the resultant going to be? It is going to be an angular bisector. Or how am I going to find the resultant using the parallelogram law of vectors? Root of
A square plus B square.
F1 square plus F2 square plus 2F2 cos.
Very good. So root of F1 square is F square plus 2F square cos of how much?
120.
120.
Also 120 degrees. So this will be equal to root of 2f square plus 2f square into my cos 120 is minus half, they'll get cancelled. So what will be the answer? Answer will be f. Because 2f square minus f square is f square. Square root of f square is f. Guys, am I clear with this?
Yes, sir.
So this force is what? This is the force acting on the first particle. I calculated only F1. Now tell me, is everyone clear with the logic of how to approach?
Yes, sir.
Will you be able to calculate F2 and F3 on your own?
Yes, sir.
Okay. So if you still need help on that, you have the solution here. Don't worry. The solution part is there. Don't worry about it. Okay. So today we discussed about the concepts that are based on the basic properties of charge. Then we discussed about Coulomb's law. So indirectly we covered the Coulomb's law in vector form as well. Then what did we discuss? We discussed about the principle of superposition, right? So in the next class, what we will do is we'll discuss about the electric field and electric field due to this different kinds of systems of charges. Okay. So what I want you all to do is listen to this carefully. So those who are new, you would have been added to the app, right? So I'll give a separate demo session for that later. So in that app itself, there are pre-recorded videos for this chapter. So which are broken into capsules. Means for each subtopic, the topics are recorded. So you can go through them before you come to the next class so that we can concentrate more on the problems part of it. Okay, it is applicable for those who are a part of our classes as well. It's not only for the students who have joined recently. Those who have conceptual doubts, please go through the concepts again and come. I have recorded and put it there.
Sir, I have a small doubt. Could you just repeat the point where you said about the positive and negative charge where we should consider it?
Okay. So positive and negative charge is simple one. You need, so you're writing the mathematical expression for which quantity in this problem? It is for force. So if you're writing an expression for a vector quantity, if you're writing an expression for a vector quantity, you will never take the sign of the charge into consideration while writing the magnitude. Here, if you see F12 and F13, I put a bar on the top of it. I wrote it only as a magnitude. Ram, are you able to understand this?
Yes, sir.
I wrote it only as magnitude. So when you write it as magnitude, you will not take the sign of the charge into consideration because I have already put the arrow marks.
Yes, sir.
Whereas when you're dealing with scalar quantities, what are the scalar quantities that are there in electrostatics? Electrostatic potential and electrostatic potential energy. When you're asked to calculate these two values, you need to take the sign of the charge into consideration.
Okay, sir.
Okay, never forget this. So is there any other doubt anyone else is having?
No,
Is
sir.
it clear? All are clear, no?
Yes, sir.
Good. So that's it from my side for today, and we'll wind up.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Thank
you.
you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Yeah.
Sir,
Who? Sriram.
yes, sir.
So
Sir, vectors, even in vector form, we don't take the sign, no, sir. The unit vector will give the direction, sir, even if it's in opposite direction.
that is what I told you.
In
So
vector
anytime-
form also, if it is a negative charge, we won't put minus.
No need,
Ah.
because see, the charge, what is it indicating you? Whether the charges that are there in the system are undergoing a pulling force or a pushing force. Attractive or
direct.
repulsive.
Yes, sir.
So that negative sign for a vector quantity doesn't have a specific significance as long as you know the direction.
Okay, sir.
Other than meaning.
Yes,
Okay,
sir.
but as
Thanks.
scalar quantity, it matters. At the end of the time,
Scalar.
you ask the
Okay.
same question at that point, I'll tell you.
Yes, sir. Thanks.
Okay.